Hello everybody and welcome to this video on CNN. So what is CNN? First off, CNN is not a TV or a news channel. It is the short form for what is called a convolutional neural network. It is a type of neural network which is inspired by neurons in the brain. And also, it's also known as a deep learning model type that deals with, so let me just make this diagram here. So you see those two eyes? So the CNN is seen to be the eyes of neural networks or deep learning. And it's because it's inspired by the human cortex vision. So the human eyes, to put simply. And this deals with images, of course, and videos. And there are three major types of tasks that CNN can be used for, although it's not limited. There are more niche areas, but the major types are object detection, two, very popular one, image classification, and the last one is image segmentation. Okay, so without much ado, let's get even right into the architecture. So let's open a new page. So now, convolutional neural network is composed of two types of hidden layers. Number one, we have the convolutional layer. Next is the pooling layer. So to briefly explain the convolutional layer, so let me just scroll down. So what does a convolution? Number one, a convolutional layer is the major component of this CNN, which is a name, convolutional neural network. Yeah. And then in a convolutional network, what does the convolutional layer do? First of all, it does a series of things. Majorly, it performs what is called a convolution operation. So in this convolution operation leads to what is called, so just stay with me, what is called feature maps. The result of a convolution operation leads to what is called feature maps. So what are feature maps? Feature maps, so this convolutional layer receives the image, the input. Let me use a different color. So yeah, so it receives the image. So let's use red. So the input, this is what happens. Input image For example, let's say it's a cat. I'm going to do my best to draw a cat. Don't laugh at me, please. Eyes, and so this is the input image. So once the input image enters into the convolutional layer, which is the first layer, it enters into convolutional layer. There's a series of things that happens. First of all, the convolutional layer applies filters. What is called filters. And let me use a different color. Let me use yellow. Filters. Applies filters to the input image. Okay, so let's even go deeper. What does it mean when it applies filters to the input image? So these filters could be in windows of 2x2, 3x3 matrix. So for example, this image, because you know the computer, our neural network doesn't understand what you just say, input image. It converts this into, because you know images are pixels. Pixels, what are pixels? When you zoom into an image, you see those boxes. So images are composed of lots and lots of pixels. So this image, for example, let's say it's a 4x3 matrix. What does that mean? Let's see this in practical terms. For example, that's 4 means height, 3 means width. So the numbers then would be, I'm just coming up with random numbers now, but the number would be determined by the image. So let's say this is a black and white image, and then matrix 4, maybe 2, 3, coming up with random numbers now. So 3, 1, 4, 0, 1, 3, and then 1, 4, 2. So these filters can either be in a 2x2 matrix, 3x3 matrix, 5x5 matrix, depends. So these filters now could be, for example, a 2x2 matrix, and like this, 2, 4, 1, 0. So this filters how a convolution, or what is called a convolution operation. So these filters are applied to the images. So I'm giving you the back end, but you know what, let's just come a level higher first of all. So let's just imagine we're working with this image, right? So the filters are applied to the image by 2x2 matrix, 2x2. It looks like this, then another filter 2x2, then another filter 2x2, another filter 2x2, like that, 2x2, 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 until it covers the span of the entire image. So for example, here we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 overlapping 2x2 matrix. So these are the filters now. Now, what does this filter do? High level now. It looks into the images and learns the details. So the first convolution layer learns, okay, the lines, the edges, lines, the edges, the textures, and everything. And once it's applied to all of the parts or the span of the image, it results in what is called, once all the filters are applied and it learns the features and the attributes, it results in what is then called the feature maps. The feature maps. So the question now is, what are feature maps? Feature maps are they represent features found in the entire input image. Let's cover this and right here. This is what feature maps are. Feature maps are maps, little maps that have in them or represent the features found in the images. So the features can be, oh, we found this line or these edges, and then the next convolutional layer makes use of those lines and edges to make sense of what is looks like an ear, a mouth, and all of those stuff. So still stay with me. We are going somewhere. So this is what a convolutional layer does. Now, concerning this maths, I will post on the maths here, but let me know if you want me to actually do a video on how it works, like in numbers. So before I go so deep into theory and you're like, oh my God. So yeah, let me know if you want me to go into the maths and I could do a video on that. And yeah, so now let's go see the second layer, second hidden layer of a CNN, which is the pooling layer. So let's say number 2. What color did I use? Blue. Okay, let's use blue then. Number 2, the pooling layer. Now this pooling layer, there are actually different types. There's the max pooling, and then there is the average pooling. So in summary, what it does, pulling down samples. In other words, or reduces the size of the output of the convolutional layer. So specifically, the convolutional layer outputs 3-dimensional data. 3-dimensional data means height, width, and depth or channels. But in the context of a convolutional layer specifically, it's feature maps. This number represents the number of the feature maps. So now, for example, our, let me put it here. Let me just signify that this is what I'm referring to. The output height, width, and depth. So for example, if the number of the output is say 2, 4, no, let me use a bigger number. Say 68, for example. And then number of feature maps, for example, is, let's say 34. So this is the output. Trying to see the best color to use, so let's use white. So this represents the output, the convolutional layer output, right? So now once it gets into the pooling layer, the pooling layer downsamples it how? By half. So that would be 34, 34, but it leaves the number of the feature maps. So 34. So now this is the pooling layer output. I hope we get it. So that's what it does. And how it does it, it could do it using max pooling. That's using the maximum value within the windows. If it's 2 by 2 or average, that's the average values. If you want me to go into the maths of how it looks like, let me know. So now back to where we were. These are the hidden layers. So now let's see the architecture, how it works. So CNN's architecture. All right, so first of, it starts with the input layer. As the image of a cat. And then it goes to the first hidden layer of a CNN, which is the convolutional layer. So in the input layer, the image of the cat enters into the neural network. Then the convolutional network applies the, let me write it. Image enters neural network, convolutional layer performs convolution operation by adding or applying filters to the input image which results in feature maps. Alrighty, well. Awesome. So next is the pooling layer. What does a pooling layer do? It downsamples the spatial dimensions. Specifically, the height and the width of the feature maps. Remember, it's the feature maps that is sent to the pooling layer because the feature maps contain the convolved input image. That's the input image that has the filters that result in the feature maps. And the feature maps represent the features learned by the convolutional layer. And how did it get its feature maps? By applying the filters to the input image of the feature maps. Let's keep going. So after the pooling layer, there could be series of convolutional layer again and pooling layer. So let me put that there. There definitely is more than one. So depends on your architecture and what you're building. That determines the number of the, and it repeats the same process again. My bad. It repeats the same process again, performs convolution operation and applies the filters to the feature map to result. So you know what? Let me just write it. So these convolutional networks leverages on the features learned in the first convolutional layer. So for example, the first convolutional layer learns edges, lines, texture. The second convolutional layer, let me just write it, the second convolutional layer leverages on the lines, the textures learned by the first convolutional layer to make sense of, okay, this lines in this certain way and shape means it's a nose. And like that. So let's go to then it goes on to the second pooling layer. So the pooling layer basically, it does the same thing. So in other words, let me explain it again. It reduces the size of the feature maps by only preserving important features. Okay, this is the second pooling layer. And we could have a series of them. We could have a third convolutional layer, then the third pooling layer, But for now, for illustration purposes, let's just pause here. So after this series of convolutional and pooling layer, the next is what is called a flattening layer. Flattening. What does this flattening layer do? It converts the 3D or three-dimensional data that we've been using, specifically the values of height, width, and then the depth, or channels, or number of feature maps. And it converts it to a one-dimensional array. What does it mean? So, which is a list of long values. So it converts our height, width, depth to, for example, e.g. 2000 values. So for example, we had maybe example of this is, we use an example previously and say, so 34, 34, 34, for example, height, width, feature maps. So I'm going to say FM. So it converts this into so it converts this into, for example, 1030125, like that, 2000. It converts this three-dimensional into one single list of lots of numbers of values. Like that. That's what it means. Why does it do that? Well, because the next layer we're about to go into, that our details and our data, or three-dimensional information, the next layer it's about to receive cannot handle 3D, can only handle 1D. And that layer is quite important. We cannot ignore it. And the layer is called a dense layer. Or some people call it fully connected layer. So this dense layer, fully connected layer, is what you're familiar with. I've talked about it when I spoke about deep learning as a video. I'll pin it up. Yeah, or you can just search my channel. That's what it's called, because all of them are connected. All the neurons are connected from the very get-go to the very end. So now what does this fully connected layer or dense layer do? What it does is that it makes the decision on the outcome based on the features learned by the convolutional layer. So for example, tries to determine if our image, because if you remember, we put in a cat image, if our image is a cat or a dog. Let me just clean this for some space. Or a dog. That's what it does. And then to the last but not the least neural network, the layer, my bad, not neural network, is what is called, you might guess it, the output. Output layer. Output layer outputs the decision of the dense or fully connected layer. E.g., this image is a cat. Yeah, so I do hope that this was explanatory. I know it could be a lot, but if you want to even know more details about it, I would say that you should wait till like 2nd of September and pre-order my book, where I extensively did justice to this topic. I really took time to explain it, the theory, the maths, with examples. So I think that would be a good one. And just trying to zoom out and zoom in here. So yeah. Okay, so a snapshot from the input layer to the convolutional layer to the pooling layer to the second convolutional layer, second pooling layer. There could be a third one, series of convolutional and pooling layer, and then it goes to the flattening layer, then to the dense layer, and to the output layer. Remember, if you want to know even more details of this, you should pre-order my book. It's coming out 2nd of September, and you'll even learn everything, the math behind it, and everything in extreme detail. Until then, thank you and bye-bye. I hope you understand it, and if you have questions, please feel free to let me know in the chat. Don't forget to like, share, subscribe, and thank you. Bye.